Hi, Mr. Wright here, and welcome to this film in which we will work our way through 6 Edexcel IGCSE questions on differentiation. Now, differentiation is one of those key topics that you need to have some fluency in if you are going for a top grade. You can download the questions by hitting the link in the description, and then you can work through the questions and then watch the film, or you can work through the questions as you watch the film and work alongside me. If you've got any questions, please leave them in the comments, and of course I'll respond. And if you find this film useful, hit like. Well, hit like anyway. It helps the channel and it will help other students looking for resources on differentiation to find this film. Right, let's get on with the maths. Question 1. I've got a cuboid here, and I'm told the total surface area of the cuboid is A square centimetres. And I need to find the maximum value of A. Let's start out by writing an expression for the surface area A. So A is going to equal, well, I've got the top and the bottom of the cube, so that's an area of 2x squared. And then I've got the 4 sides, and the 4 sides are all the same, so it's going to be 4 multiplied by, now the area of one of the sides is x multiplied by 12 minus 3x. So there's an expression for the surface area of the cuboid, and I can simplify that. 48x minus 12x squared, and again I can simplify that, minus 10x squared plus 48x. Now I'm asked to find the maximum value of A, so I'd like to know how A changes with x. So I'm going to differentiate A with respect to x. So I'm differentiating this expression here. So I'm going to differentiate minus 10x squared. So I have 2 times the minus 10 is minus 20, and then subtract 1 from the power, so it's just x to the 1. Plus, now 48x, remember that's an x to the 1 there. 1 times 48 is 48. X to the 0 is just 1. So there is my differentiated A. So that shows me how A changes when x changes. And I want a maximum value of A. So I want to know what value of x gives me a maximum. So what value of x makes the differential equal to 0? So I'm going to solve that equation. Solve that equation, quite straightforward to solve, and you will find that x is 2.4. So now I know what value of x gives me the maximum value of A. I can get on and find out what that maximum value of A is by substituting x into my formula for the surface area. So I'm going to do that now. I know that my surface area is, I know that A is minus 10 times x squared plus 48x, and I know that x is 2.4. So if I substitute 2.4 in here, let's show the examiner what I'm doing. Stick that into my calculator, I find that the maximum surface area is 57.6 square centimetres. And that is my solution for question 1. Question 2. I've got a 5-sided shape here, and I'm told that it's made up of a rectangle and an equilateral triangle. So that's length y, and those are length x. I'm told that the perimeter of the shape is 100 centimetres. So straight away I can write down that 3x plus 2y equals 100. Great. Now I'm told that the area is r square centimetres, and I'm asked to show that r is equal to that expression there. So what I'm going to do is I'm going to get my own expression for r. First of all, so what is the area of this shape going to be? Well, it's a rectangle, which has an area of xy, and an equilateral triangle. Now, the equilateral triangle looks like this. It doesn't look very much like that, but still, that'll do. Okay, x and x and x, and it's got a height. Right, so I need to find the area of that triangle. So it's going to be half the base multiplied by the height. And to find the height, I'm going to use Pythagoras. So the height is going to be x squared, square the hypotenuse, minus x over 2 squared, because that length there is half of x, despite my rubbish drawing. So let's simplify this, shall we? xy plus x over 2 multiplied by the square root of, well, x over 2 squared is x squared over 4. So I've got an x squared minus a quarter of x squared. So that's going to give me 3 over 4 times x squared, 3/4 of x squared. Let's carry on. xy plus x over 2 times root 3 over 2 times by x. Great. Carry on. xy plus root 3 over 4 x squared. Okay, there's an expression for r which I've come up with, and we can see the expression which they have provided me with in the question. I see the expression that I'm aiming for, the one on the left, doesn't have any y's in it. So I obviously need to substitute y out of my expression here. Now to do that, I'm going to use my first equation top left here, because this tells me that 2y is 100 minus 3x, so y is 50 minus 3 over 2x. So I'm going to substitute this expression in for y. So that's going to mean that r is x multiplied by 50 minus 3 over 2x plus root 3 over 4 x squared. Multiply out the bracket. 50x minus 3 over 2 x squared plus root 3 over 4 x squared. Now, often in questions like this, you face a choice at this point. I can continue manipulating my expression on the right-hand side until I make it equal to the expression in the question, or I can manipulate the expression in the question and make it equal to what I've come up with so far and make the two expressions meet in the middle, if you like. And I'm going to do the latter one. So the expression in the question so far is r equals x over 4 multiplied by 200 minus open bracket 6 minus root 3 close bracket x close bracket. Be very careful with your signs. Let's multiply that out. X over 4 times 200 is 50x. It's looking like my expression already. Now, x over 4, let's just keep it simple, shall we? X over 4 multiplied by the bracket multiplied by x. I'm just doing one thing at a time. I don't want to mess up those signs. 50x. Now I've got minus a quarter, so minus. I've got x over 4 times 6. And then times x at the end. Don't forget about that x there. So I'm going to have 6 over 4 x squared. Now I've got a minus times a minus as a plus. I've got root 3 over 4 and then x squared. And would you look at that? My expression on the left is so close to the expression I'm aiming for on the right. In fact, all I need to do is to simplify that fraction. And there we go. So these two expressions are equal. So I have shown that r does indeed equal the expression which I was given in the question. And there is part A complete. Part B. Find the value of x for which r has its maximum value. Give your answer in this form. Okay, where p and q are integers, right? I've got here my expression for r in terms of x, which I've copied across from part A. And I need to differentiate this with respect to x, and then set that differential to 0 in order to find the value of x, which gives r its maximum value, or gives a stationary point anyway. So I'm differentiating this expression 50x. Well, that's 50x to the power 1, so the differential of that is just 50 times x to the power of 0, which is simply 50. minus x squared, so 2 times 2 times minus 3 over 2 is minus 3, x to the power of 1, because I've reduced the power of x by 1, plus, I've got x squared here, so I'm going to do twice the coefficient. Well, twice root 3 over 4 is root 3 over 2, and that's going to be multiplied by x, because I've reduced the power of x by 1. So that is my differential there, and I'm going to find the value of x, which makes that a maximum, by setting this differential equal to 0 and finding the value of x, which makes the differential equal to 0. Let's multiply everything by 2. 100 minus 6x plus root 3x equals 0. Okay, let's stick everything with an x on one side. So I've got root 3x minus 6x here equals minus 100 there. Okay, now let's change the sign left and right. Multiply this side by minus 1 and multiply that side by minus 1. Okay, now I need to make x a subject, so I'm going to factorize and then divide. Remember, factorize and divide. I'm fadding it. So x will be 100 over 6 minus root 3. Now let's see. In the question here, it says I must give the answer in the form p over q minus root 3, where p and q are integers. Well, I've done that, haven't I? So that is my answer to B, part 1. Find the value of x for which r has its maximum value. I've done that. Good. Part B, part 2. Explain why the maximum value of r is given by this value of x. Let me just take a moment to make sure that you're clear on what the question is asking you here. What we've done is we've had an expression for r, and we've differentiated that and found that it has a stationary point at that value of x. But the problem is, of course, that if the function of r looks like this, then the stationary point is a minimum, not a maximum. Whereas if the value of r looks like that, then the stationary point would be a maximum. And what the question is asking you is, how do you know that we're dealing with a function that looks like this one? So this is a maximum rather than a function that looks like that one. So to answer the question, you need to explain that in our function r, we have a negative coefficient on the x squared. Therefore, we are dealing with a curve which is shaped like this, and therefore the stationary point is a maximum, and that is how to approach that question. Right, question 3. We've got a diagram with a sketch of part of the curve with this equation, y equals x squared minus p over x. I'm going to write that as p multiplied by x to the power of minus 1, where p is a constant. For all the values of p, the curve has exactly one turning point, and there it is, look. And this turning point is the minimum, shown as the point t. For the curve where the x-coordinate of t, the x-coordinate of the minimum, is minus 3, find the value of p. Now, if the x-coordinate of the minimum is minus 3, then the differential, dy by dx, must equal 0 when x equals minus 3. So all I need to do is to find the differential and set p so that the differential equals 0 when x is minus 3. Let's start off by finding the differential of y. Now I know that y equals x squared minus p x to the minus 1. So I'm going to differentiate y with respect to x. That's x squared, so 2 times the coefficient of x. 2 times 1 is 2, times x to the power of 1. Subtract 1 from the power. Right, this second expression, I've got a power of -1 and I've got a coefficient of minus p. So -1 times minus p, that's going to be plus p x to the power of -2, subtracting 1 from the power. So that's my differential. And I know that this differential equals 0 when x is -3, because -3 is the x-coordinate of the minimum. So I'm just going to substitute in x is -3 into this. So I'm going to have not 2 times x, but 2 times -3 plus p over, not x to the power of -2, but -3 to the power of -2, which is going to be p over 9 equals 0. So that's -6 plus p over 9 equals 0. So p over 9 equals 6. So p must be 54. 6 nines 54. So find the value of p. I've done that, and p is 54. That's part A complete. Okay, part B. I've got a line with equation y equals k, and that's tangent to this curve here. And I need to find out where that is. Let's draw a diagram. Here's a set of coordinate axes. I've got the line y equals k. I don't know where k is, but let's imagine that that is the line y equals k, which would mean that that is k there. Okay. So this curve is going to be something like this, isn't it? Now, if that line y equals k is a tangent, it must touch the curve at a maximum, mustn't it? So really what I'm being asked to find is where is that maximum? Or specifically, what's the y value of that maximum, the y coordinate of that maximum point? So we need to find the maximum of this curve. The curve we need to find the maximum of is y equals x squared minus 16 times x to the power of -1. So I'm going to start by differentiating that, because then I can set the differential or the gradient function equal to 0 to find the x-coordinate of the maximum. So let's differentiate this. Differential of x squared is 2x. Now I've got -16. I need to multiply that by -1. Gives me plus 16, x to the power of not -1 anymore, but -2. So that is my gradient function. And so I need to solve this equation. I need to find out what value of x makes my gradient function equal to 0. So I'm going to multiply everything by x squared. Gives me 2x cubed plus 16 equals 0. So 2x cubed equals -16. So x cubed equals -8. So x is the cube root of -8 minus 2. So I can see now that that x-coordinate is -2. I appreciate the y-axis is in the wrong place, but it doesn't matter. Now, I'm asked to find the value of k, so I need the y-coordinate at that point. So I'm going to need to go back to the equation of the curve, and I need to substitute in x equals -2 and find what y is. Well, -2 squared is simply 4 minus 16 over -2. So that is going to be 4 plus 8, which gives me a y-coordinate of 12. So this line here, the line y equals k, must be the line y equals 12. And the question says find the value of k. So my answer is that k is 12. And that is that question complete. Question 1. I've got P and Q, and they're moving along a straight line, and the fixed point O lies on the line. Okay, so here's my straight line. Here's the point O. Okay, now let's take particle P to start with. It's always a certain distance from O. Okay, now it might be moving away from O, or it might be moving back towards O. How do I know whether it's moving away from O or towards O? Well, this S, that tells me the distance of P from O at any given time. So if the distance is increasing, then P is moving away from O. And if the distance is decreasing, P is moving towards O. So I'm going to differentiate the distance of P from O with respect to T. And that expression will tell me whether or not my particle is moving away from O or towards O. Essentially, when this expression is positive, then the distance is growing and my particle is moving away from O. And when that expression is negative, then the distance is decreasing and my particle is moving towards O. Let's take a moment to establish when this expression is positive and when it's negative, because that would tell me which direction my particle was moving in. So I'm going to start by solving this equation, which I'm going to do by factorising here. It's going to be a -5 and a -1. So that's going to give me t is 5 over 3 or 1. So that tells me the roots of the equation there. So my graph is going to look like this, isn't it? This, by the way, is t. I'm only interested in values when t is positive, of course, because we're not dealing in negative time. There's 1. There is 5/3. And the function looks like this. So this function has a negative value when t lies between 1 and 5/3. And it has a positive value when t is less than 1 or when t is greater than 5/3. So my particle is moving away from O when the distance is increasing, when it's positive, and it's moving towards O when the distance is decreasing and my function is negative. Good. So that tells me when that first particle is moving to the left or to the right. Okay, let's look at the second particle now. The second particle is Q. And sometimes it's going to be moving towards O, and sometimes it's going to be moving away from O. And I've got an expression for the distance here. So I'm going to see how the distance changes with time. dx by dt is 2t minus 4. Okay, 2t minus 4. Well, that's a much easier graph to be thinking about. It goes through here at -4. Okay, and it's going to cross here at 2, and of course it's a straight line. All right, there's my value of t. So this time the function is negative, the distance is decreasing when t is less than 2, and it's positive when t is greater than 2. Okay. Now, I was asked to find the range of values where both particles are moving in the same direction. So either they're both negative or they're both positive. Okay, so let's have a look here. My particle on the left is negative when t is between 1 and 5/3. And the particle on the right here is negative as long as t is less than 2. Okay, well, the time in common there then is when they're both negative. They're both negative when t is between 1 and 5/5. So they're both moving negatively there. So that's good. Now, what about, is there a time when they're both positive? Let's have a look. Well, the one on the right is positive as long as t is greater than 2. Okay. And the one on the left is positive as long as t is greater than 5/3. So as long as t is greater than 2, then they're both positive, aren't they? So the times when they're moving in the same direction is either when t lies between 1 and 5/3 or when t is greater than 2. So let's write that really clearly. And that is the solution to question 1. Question 2. Okay, another particle question. Here we go. A particle moves along a straight line that passes through the fixed point O. Fine. Let's just draw that. Here's my straight line. Here's O. My particle moves along here. Now the displacement, x meters of P from O, how far away is P from O? More or less. Okay, is given by this. Okay, so that is the distance, the displacement of P from O. So obviously that's going to change over time, isn't it? I could see how it changes over time by differentiating x with respect to t. How does the distance of P from O change over time? 12t squared minus 27. Okay, now I suppose sometimes my particle is moving further away from O, and sometimes it's moving closer to O. And look at this. The direction of motion reverses when P is at point A on the line. So I wonder when that happens. At what time does the direction reverse? Well, let's find out when that change in displacement is equal to 0. Because when the change in displacement is equal to 0, that is when, so t is going to be root 27 over 12. Right, so that is when my particle comes to a halt and then goes the other way, reverses its direction. Now, the acceleration of P at that point, at this time, is a square meters, a meters per second. Find the value of a. Well, the acceleration is going to be given by the second differential, isn't it? d2x by dt squared. So that is 24t. So all I'm really being asked to do is to evaluate 24t when t equals the square root of 27 over 12. And I'm beginning to wish I had my calculator now to work that out. But into my calculator, I would simply have to write 24 times the square root of 27 over 12, and that would give me my answer for A. Right, now wait a second, I've had to come back to this because I've just been thinking about it. I've got 24 times root 27 over 12, and that is going to equal 24 times the square root of, I can cancel 27 over 12. 3 goes into the top and 3 goes into the bottom. And look at that, now I can square root 9 over 4. It's just 3 over 2. So actually, my answer is simply 36. And that is the value of A. Okay, so that was a bit easier than I thought. I didn't need a calculator at all. Right, there you are. That's definitely now the answer to question 2. Question 3. Right, my curve C has this equation. Let's just write that a little larger. It's y equals 1/3 x cubed minus 9x plus 1. And first of all, I'm asked to differentiate that with respect to x. Okay, I think we can do that. So 3 times 1/3 is 1. X, not to the power of 3, but to the power of 2. Minus, now this is 9x to the power 1, so 1 times 9 is 9. X to the power of 0 is simply 1, so 9 times 1 is simply 9. And that is that differentiated. Good. Find the range of values of x for which c has a negative gradient. Well, this is the gradient function. And so I simply need to find the range of values when that is negative. Okay, well, there are a few different ways you can do this, of course, but I hope you recognize that that is the difference of 2 squares. So we're solving this equation here. So if I can picture the graph, x, y, okay, it goes through 3, minus 3 and 3, looks like this. something like that. And I need to know when the function is negative. So the function is going to be negative when x lies between -3 and 3. And there is question 3 sorted. Well done for making it through to the end of 6 really quite complex grade 8, grade 9, I would think, questions on differentiation. If you found the film useful, please hit like. Please tell me so in the comments. And if you've got any questions, of course, leave them in the comments and I will respond. Thanks very much for watching. See you in the next film.